love, a mere 3 days after Carl and I had fallen deeply into true love. The idea that that's on the Voyager record, my brainwaves, in a kind of joyfulness that has proven every day since to have been completely well-founded and valid. That's really meant everything.
The essence of one human being's physical presence in the universe, I would say. You know that we love, whenever we get the opportunity at the Planetary Society and here on this show, to listen to or repeat what I am going to call the pale blue dot soliloquy. If you could take us back to that fight that Carl and you waged to turn Voyager around when it was past Neptune and look back at our home planet.
Well, that was all Carl. That wasn't me. I of course, I'm sure I encouraged him, but it was Carl's brilliant idea in 1981 to appreciate that when Voyager had taken its last pictures of the worlds of the outer solar system after the Neptune encounter, that Voyager 1 could now turn its cameras homeward to look at the sun and its retinue of planets. He started lobbying NASA in 1981, 8 years before the last Voyager encounter, saying, would they please arrange to take these last pictures of the home planet and its sibling planets. And NASA, for the first 6-7 years, was completely resistant to this idea. And they would say things like, it'll fry the lenses of the camera to look towards the sun. Of course, the camera.
What else was there to look at?
Not going to be used ever again.
Really?
You know? Or they would say, what's the scientific value of such a picture? And Carl understood that here was the potential for the greatest teachable moment, perhaps in human history, at the time it was most urgently needed, to actually see our true circumstances, to understand the Earth as a mere pixel in the solar system, let alone the Milky Way galaxy and the universe, to take us, to wean us from our delusions of importance and centrality, but also to wean us of the delusion that this Earth was infinitely plunderable and exploitable, and that we could go on ruining the environment that sustains us without ever having to be held accountable for these crimes. And so he would schlep to Washington, D.C., to NASA headquarters on numerous occasions. And when he was out at JPL pleading to have this picture taken. And it wasn't until, I believe, around the time of the Neptune encounter that he was first told that they had decided to do it. And so on Valentine's Day, 1990, imagine the beautiful Voyager 1 rising from the plane of the solar system and all the dust and looking down.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello, and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, and alumni and friends of York University. I'll be one of your hosts this evening. My name is Julie Tomei, and I will be joined by Dr. Elena Hyde. Hi, Elena.
Hello, hello. It's great to be here.
Thank you for joining me this evening for yet another episode of the Julie and Elena Show. We are broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That is Tuesday morning at 1 a.m. Universal Coordinated Time. York Universe is a production that works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 p.m. and 10 p.m. local Toronto time. So head over to observatory.info.yorku.ca and follow the links to OPV for online public viewing and join the chat. Our broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter, where our handle is at York Observatory, or on Instagram, where we have the handle at York U Observatory. And on Facebook, you can find us at Alan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, we certainly won't say no. Please head over to our website at that is observatory.info.yorku.ca. We will be monitoring the chat room for questions and posting content. The current weather in the area is cloudy and rainy. So no live images this evening. It will be archival content over at the online public viewing, because we like to keep our equipment dry.
We sure do. It's basically one of my favorite things.
Yes, definitely. A lot easier these days. How's the dome project coming along?
It is actually excellent. I am very happy to report to anyone who is following along with the new domification that's been happening this summer. Our new domes, in fact, do not leak at all. 0 water drops come in. None gets through the shutter, none gets through the edges, and we have a completely dry setup as long as we don't open when it's raining. So that will be no opening tonight.
And everything's communicating and happy?
Well, we are trying to install some rather complicated computer electronics. Our old computers right now are actually hooked up to the new system and running a communication interface. So we're in a little bit of a intermediate stage while we're waiting for the new computers to run the new control system to talk to the new domes. But we're in, let's say, 80% electronics mode, so we can't actually run programming yet, which has been our really, really fun one. And programming observing means that you can actually write code that tells your telescope to, for example, go to a certain star, take a certain number of exposures of that star, follow it across for the night, and then park the telescope and close the dome. So you can write those programs and have it run once we have the new computers in. So we're still waiting for that capacity, but everything else works.
So tantalizingly close.
It is very, very tantalizingly close. We do have a lot of new stuff coming in almost every day. Electronics and power cables and uninterruptible power supplies. Oh, new screens. Oh, they're really cool. You're going to love them. And we are actually going to open up 4 tours as soon as we finish checking that all the electronics are really, really safe. And as soon as I'm done putting in a few of those Cosi Rosenthal air filter boxes.
I just learned what those are today. So cool.
They're really fun. I love them. My new favorite project.
Yes. Inexpensive air filtration thing. Basically, like for anyone out there who don't know, picture furnace filters in a box configuration, and then put one of those big square inside the house fans on top. Turn it on. Filtration system. Boom.
Yeah, they're actually quite excellent. And I believe you can get pretty large sets of those, even at just Canadian Tire at the moment. So I think I got a pretty good deal on a big stack of them. And there's a whole bunch of different designs. There's a triangle design with 2. There's the 4 design. There's a 5 filter design. And there's a 1 filter design that was actually the original. So the original was actually just take a filter and literally like rubber band it to the back of your fan.
Love it.
Love it. It works really well. It's well tested, and you gotta love it when they produce the science behind there as well. So a big fan of science, and maybe not too big. Let's say 20 inches of standard fan size. But anyways, very, very good for putting in your observatories and keeping the air nice and clean so everyone can come by and view. Once you have your observatory, then of course you can do the viewing if it's clear.
Yes. So stay tuned, folks. Soon.
Yes.
We'll have all this worked out and in-person public viewing.
We do actually already have that at the atrium at the observatory.
Yes, and the atrium is cool.
Yeah, for old fans of the observatory.
1 meter telescope.
Yeah, and you have to be an old fan of the observatory to know about the 40 centimeter, but the 40 centimeter is out at the atrium. So if you are having nostalgic thoughts about smaller telescopes, it's a great outdoor location, completely open air. But the 1 meter is amazing at producing detailed images of things like Mars, Saturn, Jupiter, and even Uranus and Neptune.
40 centimeter will always hold a special place in my heart.
Yes, as it will with anyone who is out there, I think, late at night and trying to get the hand pedal to work.
Yes. Well, I mean, it was brand spanking new when I was at York, so we didn't have any troubles with the hand paddle. All right, let us move into our first item in this week in space and astronomy history.
Oh, excellent. Well, I've actually spoiled a little bit of it already because I was talking about viewing things. And I thought, to start us off tonight, we can't really see much tonight, but right now there are a lot of interesting things up in the sky. And in particular, it is really fabulous for planet viewing. And in September of 1952, was the last time that Jupiter in particular was this close to Earth. It's not actually the closest yet, but because there are so many good things up right now, I thought this week in space and astronomy history, well, it's actually all it's the past present, because we have so many good planetary views happening. It is actually just an excellent time to go outside, look uppity, even with binoculars. It'll be pretty fun. Even with your naked eye, you can actually see quite a lot because Jupiter is very, very bright, the brightest it's been since 1952. And it is going to keep on getting brighter. So I thought, well, let's astronomy is all about time travel anyways. So let's talk a little bit about what we can see up there. And, with the in particular Jupiter rises at about 8 p.m. and sets at about 8 a.m. So it's actually going across the sky almost all night. And it is very, very bright. So you will not be able to miss it, even in downtown Toronto. If it's not cloudy, Jupiter is up most of the night, and it will be very striking. It actually is very frequently confused for an airplane. So if you see something low on the horizon early in the before sunrise or just after sunset, it's probably Jupiter if it is not twinkling and not moving like a plane. So that is one thing to definitely look forward to. We do also have a bunch of other planets that are great to view out right now. So if it does clear later on this week, doing planet imaging, especially of the surface of Jupiter. Jupiter is also in a nearly what they call a full phase, where we're catching most of the sunlight reflected back to us, so we can image Jupiter very, very well at the moment. So this is an excellent thing for something Julie mentioned. Is, of course, our 1 meter telescope would be an ideal thing to target, because we could put on a very, very strong filter to block most of the light and get probably some pretty good images of Jupiter and its moons. And if you are up watching Jupiter, why not also catch Saturn? Continue the tour of the icy outer solar system. Saturn actually is also up most of the night after sunset. It does set a little bit earlier, so 4 a.m. So if you're planning, I don't know any of that 4 a.m. observing, I wouldn't suggest it, but Saturn will be setting around then. And we
know me, I'm always observing at 4 a.m.
I only do it if I'm staying up all night. Waking up at 4 and then going off is too hard. So if you are staying up late, you can easily catch Jupiter, Saturn, and actually you might have a chance to catch Uranus. It does rise at 9:43 p.m. and then it sets around 12:08 p.m. So you can catch Uranus if you have a good enough telescope. So you do need a serious telescope for this, and probably some reasonably dark skies. We have imaged it before, again with the 1 meter. The 40 can do it. It's a little bit fainter and blurrier. And Neptune's out as well. So you've got Neptune, Uranus, Saturn, Jupiter, and even a little bit of a chance at Mars. So Mars doesn't rise until about 11 p.m. But if you're up around midnight anyways watching Jupiter and Saturn, you might as well catch a little bit of the red planet. So we have all of these wonderful things to image up in the sky, and we're just coming off of a really, really impressive full harvest moon, which is rising around 9 p.m. And then it's actually, so Jupiter rises first, and then the moon, which is still 90-something% full, 91% full, and then it's following Jupiter all across the sky throughout the night, which is just amazing and fun. And if you get a chance to do viewing this week, I highly recommend it. For those of you who might have missed the harvest moon, that was back on September 9th, and that was the closest full moon to the autumn equinox. So we are done with that, just in case anyone is keeping track. But there are so many good things to catch at the moment. I'll just give a special shout out to Jupiter for all of September, really, but especially this part of sort of early-ish September, as we get to the darker part of the evening, darkness falls, Jupiter rises, it goes across the sky all night, and by the time we get to September 26th, that will be its opposition, and it will be rising in the east at sunset. So that's something to look forward to as well. And just in case you were wondering, opposition or its closest point to Earth, is actually still not that close. That will be 3.953 astronomical units, or 3.953 times farther. So that's the distance from the Earth to the Sun. So 3.9 times more than that away from us. And if you need miles, that's 367 million miles, 591 million kilometers, or 33 light minutes. And light minutes are probably the best way to measure anything, I think, because the time travel for light to get there gives you an idea of how far away it is really. The moon is only 1 point something seconds, light seconds away from Earth. So being 33 light minutes, it's still pretty far. The solar system is huge. So this is the last time Jupiter was this close to Earth. It is very exciting, and it's a little bit of history, as I say, past made present. So I hope you all do get a chance to look uppity, and I hope those pesky clouds go away soon.
Yes, get out there and look up at some planets. And now I am looking at a forecast. Da, da, da.
I hear it might
Day.
partially clear around midnight tonight. So if you are up late, maybe give a peek.
It's supposed to be clear tomorrow night in this area. So
yeah,
if you're in the
should be
GTA tomorrow night, get yourself outside. Look up. See those planets. Look at that moon. Don't miss out. I mean, they'll still be there later.
And if you do have a planisphere, you will be able to get a couple nice constellations as well. So you might even be able to find Pisces the fish. That's where Jupiter will be when it is in opposition. It's not quite there yet, so you can actually see how Jupiter will be marching its way across the sky. So it's near the Great Square of Pegasus at the moment, I believe.
Yes, that is one of my favorite fall ones.
It's an excellent fall constellation.
It is so big. All right. So, we mentioned the moon a few times. You may see a theme coming up this evening.
I see what you did there.
Today, yeah,
rising just after.
I believe they call those segues. Today is the anniversary. In 1962 was the speech, the famous "We choose to go to the moon" speech. The official title of the speech was the address at Rice University on the nation's space effort. It was given, of course, by John F. Kennedy to inform the public about the plan to land a man on the moon by 1970. It was largely written by advisor and speechwriter Ted Sorensen. It was delivered to a large crowd of approximately 40,000 people at Rice University Stadium in Houston, Texas. The speech characterizes space as a new frontier. It invokes the pioneer spirit, has a sense of urgency and destiny, and emphasizes the freedom enjoyed by Americans to choose their destiny rather than have it chosen for them. It calls for competition with the Soviet Union, but also proposes making the moon landing a joint project. That was turned down by the Soviets. The speech resonated widely and is, of course, still remembered today. There was, mixed feelings about the cost involved and the value of the moon landing effort. I mean, surprise, surprise, we still have lots of people around who question the cost of space exploration. And we can discuss that ad nauseum. And the goal was realized, as we know, in July of 1969 with the Apollo program's successful Apollo 11 mission.
That was such a wonderful, wonderful mission to Apollo 11. And I mean, even at the time, you could just the excitement that mission generated. It's well before my time, but I still you go back and read the old articles and you still get a little bit of goosebumps from it.
Oh yeah, absolutely. And I mean, it's interesting, right? Like there aren't that, I mean, I don't know. I wasn't raised in the States. You were, but I don't know how many like presidential speeches are that well known. I imagine it's not that many.
No. Well, okay. So it does, I suppose this is a very individual question for all people. So everybody has their own ability to like those things or not. But I don't think I ever actually listened to one. But this one, of course, you do know about, you read about it, and it's sort of become part of the I don't know, the cultural history sort of thing. You absorb it even if you've never heard it or never read it. You still know about it. And the interesting thing with these missions is that I think that one of the things that came about was that they were so excited when they went to do their public communication. It was all very very hopeful and exploratory, but there wasn't a lot of articles about just how difficult it really was to do this. It was an incredible effort. It was an effort of brute force. It was an effort of technology. It was an effort of engineering, and all of these things coming together by an absolutely crack team of experts who just were able to make it happen. And they still had some pretty scary issues, but because it was so difficult, we learned so much from these missions. And it wasn't just propagating technologies that we now widely use, like solar technology, solar panel technology, that kind of stuff, but it's really, really interesting because it is still I think part of the whether the subconscious maybe, and it's something that it's always been like a little bit, it's still a bit too bad that we weren't able to go back yet. And I think, just to spoiler us later, I think that is one of the reasons why the moon does still have, most people do have a bit of a soft spot for the idea of going back to the moon. I know I certainly do.
Yes, soon. Yeah,
Yes.
I mean, they did those things not because they were easy, but because they were hard. At least that's what the speech said.
Because they were interesting might be better, but that's just me.
I mean, that's not what the speech said.
No, that is not what the speech said.
I probably a bit of both. I would imagine.
And it should be interesting and fascinating if you want to do it. So definitely I would say, much like pursuing astronomy and physics, if you're not having a lot of fun while you're doing it, it's probably not a good idea, because otherwise the math will absolutely get you in the end.
Oh yeah, absolutely. Never would have made it through that degree if I weren't enjoying myself at the observatory.
Exactly.
Yeah.
The math certainly would have gotten me otherwise.
Oh, for sure. Well, let's continue on the moon. We're actually going back a few years.
Yes, so obviously going to the moon has been an epic exploration of all of humanity. It really got started with, of course, the moon race. But in order to have a moon race, we kind of had to have somebody to race against. And just about 3 or so years before the speech, there was a very provocative launch by the USSR of a Luna 2 spacecraft, which went all the way out of Earth and all the way to the moon and smacked into the moon. So this is 63 years ago. Or so. And this was basically after the space age had kind of opened. The Soviet Union and the US had both set their sights on the moon. It is substantially closer than anything else. As we were mentioning, the distances to Jupiter before. And the moon is a likely target for exploration. So both the Soviet Union and the US did want to go explore the surface. Robotic spacecraft were kind of the first thoughts. And in 1958, the Soviet Union actually did approve the development of a series of spacecraft. So we've talked about their series of spacecrafts before on this show, and this was the Luna series. So this is Luna 2, and its job actually was to crash into the moon. So it wasn't an accident. They did it on purpose, and it's not called crashing, it's called impacting. So if you do it on purpose, it's an impact, not a crash, apparently. So they wanted to send a spacecraft to impact the surface, and then another one that would actually take pictures of the moon's hidden far side. So the same time they were doing this, the US said, well, actually, we're going to go study the moon too. And they built the Pioneer spacecraft, which of course get much more famous later on. And the Pioneer spacecraft was also going to try to study the moon. So the first 3 Soviet attempts to reach the moon ended in various kinds of launch failures, which is actually something that we will be talking about as well today. Launching rockets is hard. They are very explosive. And the Soviets had some problems with various anomalies on their old R-7 rockets. And so finally, they launched the spherical spacecraft, and I believe this was a cosmic rocket. So it was actually called Cosmic Rocket, which is then renamed Luna 1 in 1963. And it was a 796 pound spherical craft, and these old spherical designs are really quite something. If you haven't seen any pictures, definitely go look it up. They're really cool. And it has 6 scientific instruments. They're going to monitor radiation, magnetic fields, micrometeorite impacts, so how many little things did they get impacted with, and the rocket's upper stage would provide the thrust they need for escape velocity. And then, of course, they would go to the moon. So they had a bunch of issues. They had, of course, one stage firing longer than they were hoping, and the probe missed the moon by about 4,000 miles. So despite the moon being reasonably large, there's a lot of space out there, so it's kind of easy to miss it. And on the way to the moon, they actually had an upper stage release sodium gas, which created a cloud, and astronomers on the ground were able to photograph it. So it was a really exciting, energetic time, and this kind of display, giant cloud of gas created in space that astronomers could photograph. This was very, very showy, and so you could imagine that with the Soviets having all of this showy successes, when they finally did get Luna 2, they actually were able to impact the surface of the moon. And by this time, they had generated a lot of attention and press, and it really kicked off the space race, I think. Or at least it really gave it a kick. So Luna 2, if you want to know where the crash site is, if you've got a moon map out, you can find Luna 2 sort of in between Mare Inebrium and Mare Serenitatis, if I'm saying that right, Serenitatis. I'm not so good with moon names. But you can't see it with binoculars. It is a very small little crater. So there are models of Luna 2 that you can actually still see on Earth, I believe, in some museums. And there are also little pins that you can get. Of course, one of the great things was not only crashing on the surface of the moon, not only creating a gas cloud, but they did actually get a picture of the moon's far side later on with Luna 3. So they were able to have some very, very good success with this remote satellite. And of course, then the Pioneer lunar probes came out, and they had sort of limited success. And well, most of you know the rest. It was a lot of activity, a lot of competition, and a lot of really interesting moon missions.
Absolutely. And yeah, I did go and look at a picture of it. It looks so space age.
I love the old designs. I'm like, more spherical spacecrafts.
It looks like something that you could put on, like, you know, like a 1950s like thriller movie poster about space aliens.
As far as I know, they didn't find any aliens on the moon, but if they had, maybe that would have been a pretty cool encounter for
also
them.
Fairly certain no space aliens there.
Yeah, not as far as we know. Unfortunately, the lunar environment is not very hospitable, which is something we will have to deal with if we do send people there for longer periods of time.
All right. Well, sticking with the moon.
Yes.
Moving to a different country.
Excellent.
It's not just the United States getting in on this moon action. September 14, 2007 was the launch of Selene, a spacecraft by JAXA, which was also known as Kaguya. And that name was selected by the public and comes from a folk tale from the Heian period. Kaguya was a lunar princess from the tale of the bamboo cutter. And the satellite had a couple of sub-satellites originally called R-Star and V-Star, and they were also named after characters from the tale. So their names were subsequently Okina and Ouna. The mission objectives were to study the origins of the moon and its geologic evolution, to obtain information about the lunar surface environment, and to perform radio science, especially precise measurements of the moon's gravitational field. It had a bunch of instrumentation on board: terrain camera, X-ray fluorescence spectrometer, a lunar magnetometer, a spectral profiler, a multiband imager, a laser altimeter, radar sounder, gamma ray spectrometer, charged particle spectrometer. They were doing all sorts of spectrometry.
This sounds a lot like the watch that I tried to design when I was in like 8th grade.
Plasma analyzer, an upper atmosphere and plasma imager, and like some radio wave repeaters and radio source for VLBI, which is very long baseline interferometry. This is where the radio science comes in. So the major results: there was an improved lunar global topography maps generated, and the detailed altitude and geological data were provided to Google to make the Google Moon 3D. Nice side note there. There was a detailed gravity map of the far side of the moon generated. It was the first optical observation of the permanently shadowed interior of the Shackleton crater on the lunar south pole. And there's also evidence of Earth's oxygen being transported to the moon via magnetospheric ions.
That is so cool.
It completed its planned observations in October of 2008 and began extended operations after that, and was impacted into the moon at the southeast near side on June 10th, 2009.
Wow, that
More
is
lunar effects.
yeah. They really do have quite a bit of everything going on there, and it is actually very much worth emphasizing that the JAXA missions have been really, really key in a lot of lunar exploration, especially in recent years. And I believe they also have a plan for the mid 2030s for lunar exploration of their own, in addition to, what we might have heard here in Canada about NASA and ESA and the space agencies. But JAXA is actually trying to specifically make a plan as well for using water extracted from the moon's ice deposits. So they're still doing amazing things as well, even now.
Cool. I can't help but feel like JAXA is just kind of like, yeah, you guys do your flashy stuff. We're going to do stuff that's just as flashy, just like quietly. Or maybe it's just because we don't pay enough attention to them.
But we should do a JAXA. We should do a JAXA episode. But
we totally should.
All right. Well, not this week though, because I don't have those stories prepared. But we should definitely do one.
Yes.
All right. So moons, yes, and of course that being more of a recent lunar mission as well, it kind of gets you the idea of what you can do with these smaller spacecrafts, because the Selene spacecraft wasn't exactly this massive bulky thing, right? I forget what exactly the weight was, but it was, as I recall, one of the on the smaller end.
I'll look it up.
But the moon is well and truly back on everyone's destination list. It is getting a lot easier to get into low Earth orbit at the moment. Of course, we do have a lot of things happening. So while you're looking up, shall I go on to my last little moon aside?
I have launch mass of 2,900 kilograms. 2,900 kilograms.
Is that the launch vehicle?
Well, that's what's listed under spacecraft properties. Hold on. Maybe that's the whole. Seems really big.
Yeah, that's a lot larger than I thought it would be.
Yeah, no, mass 2,900 kilograms.
Excellent.
He's a big boy.
Well, I suppose
the small relay satellites. The relay satellites were 53 kilos each.
Yes, that's what I was thinking of, the relays. And of course, with the smaller satellites and relay satellites and CubeSats now, a lot of these things are single instrument small satellites, which is another popular way to go if you don't want to try to put everything into one satellite.
Yes. I mean, with the number of instruments it had on board, it had been.
Yeah, that's quite the list right there.
It was supercharged. So what was your last moon?
Oh yes, so I did put one extra moon bit on here.
Because this week in history.
Yes, but well, it's sort of this week in history, but kind of to round off our discussion of the moon, really, because now we've talked about the Selene spacecraft, which is, that was just in 2007, and it had so many interesting instruments. We do now have such a better map of the moon, and it's not just, Google Moon 3D, but also for, of course, finding, as I say, they have now confirmed water ice on the moon. Not a lot of it, but definitely there. So if we're going to go to the moon, I thought, why not pull in some interesting moon and Mars contrasts from different studies that people have done, because if you are trying to go to the moon, if you're trying to go anywhere actually out in space, there's a bunch of different problems that you might encounter. So just a few years ago, in 2020, there were, I think you'll be surprised to hear this. So two scientists came up in the year 2020, 2 years ago.
Stuff happened in 2020?
They came up with an experiment in 2020 to self-isolate for 61 days. And they were paid to do this. This was an actual research proposal, I suppose. I'm assuming they were paid. But I find it incredibly interesting that this actually coincided with September of 2020. They got themselves small pods, because of course in space you are very isolated, and so if you are on the moon, you might find yourself living in a very, very small, very, very isolated environment. So for 61 days, beginning in September of 2020, two space architects, which is their self-designated title, designed this experiment to simulate the lunar environment. They developed a airtight, portable, folding pod that they designed, and they placed the pod in northern Greenland in the Arctic region. The pod was designed to be environmentally friendly, no waste left behind. So they claimed that it would be able to withstand local threats. Even a polar bear was not able to get through.
Breed
Polar bears, which you would not have to worry about on the moon, but we're pretty sure. But yes, they did get a visit from a polar bear during the course of the study. They were fine. And the purpose of this study was actually to investigate the psychological impact of social isolation in harsh environments like the moon. And this kind of thing has been done many, many times. Of course, we have had studies from things like submarine crews who have been on very extended missions, and other types of studies indicating that depending on the person involved, if they are able to adapt to an isolated environment, they could actually be pretty much fine even under very, very long time periods. And so, of course, making this particular study was kind of a fun little aside, really, when I found out that they did actually start it in 2020. They did keep diaries and completed every day a 20-minute questionnaire. And they had no internet access, but they had a satellite phone to send daily messages, which is kind of probably what you would start with on the moon. If you got a good enough connection set up, you just have to deal with that 1.3 or so second delay from the light travel time, of course, between the Earth and the moon. But they were basically fine. They were able to address a few things that they thought would possibly help, that you might actually get a hobby is what one of the takeaways that I got from that. Have a hobby of some kind so that you do keep yourself busy. So this moon habitat project I thought was really interesting. It does cover, it was September of 2020, and they did actually do this. The publication from the study is actually coming out this year, so feel free to give a search for that if you are so curious. And as a contrast, of course, it's not just about the psychology of the humans. The atmosphere and the environment of the moon itself is very, very harsh. You don't have an atmosphere. You don't have a magnetic field to protect you from harmful solar radiation. There's all kinds of things to keep into account. And one of the simulations that they have done which is also a September simulation. This was the 2019, so a year before. They simulated microbes, taking an entire trip, not just to the moon, but all the way to Mars via a high altitude balloon. And this was Mars X. I think it's supposed to be pronounced Mars Box, but it's Mars capital B capital O lowercase x. So I'll call it Mars Box for this. But they launched this balloon with microbes and made it simulate a flight to Mars by keeping it in this altitude of about 127,000 feet. And they were able to actually survive. The microbes were able to survive the Mars-like habitat in the sky. So, not as harsh as the moon's environment, but there is, some interesting tidbits from this and other studies that harsh environments might be survivable, especially with some of the current technology we have in terms of using local soils, being able to grow local plants, and of course using things like moon rocks and Mars rocks as kind of natural shieldings for whatever kinds of houses or foldable habitats that we happen to put up there.
I'm just asking what kind of microbes.
Oh, what kind of microbes? Yes. So this was a set of microbes. Let me see if I could get the boxed up microorganisms. Aspergillus niger. So if you are a, I suppose, biology or microbiology person, you can tell me that I probably pronounced that wrong. So the survivors of the microbes were Aspergillus or Aspergillus niger, which is a common environmental fungus that can be used to produce a wide range of useful compounds, including antibiotics. They're actually they've done a lot of tests on these. They've heated them, they've exposed them to chemicals and stressors. But until this experiment, nobody had ever actually tested to see if they would be able to survive off of the planet. And the answer is apparently yes, to some extent, at least in a Martian-like environment. So if you did bring these on a spacecraft to Mars, they would survive there. Whether or not we want to do that is another question. But if they're useful and they're something we could grow, especially for antibiotics, this is an in situ thing that could be produced.
Yes, not all microbes are bad.
There's some
most of them are very useful.
A lot of very good microbes needed for us humans.
Yeah. Well, folks, you are listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Head over to observatory.info.yorku.ca to join the online public viewing for the chat, questions, content. You are listening to Julie and Elena. We are just wrapping up our This Week in History of Space and Astronomy, and we are now going to do the news.
Hooray!
Hooray! Except it's not the most fun news.
Oh, right. No, the news is sad. Sorry.
The news is kind of sad. So I'm sure that many people listening to this show have been following closely the Artemis 1 launch attempts. Of course, the first attempt was scrubbed before our last episode when Ryan and Quentin were on, and the second attempt was made on September 3rd. And that was scrubbed as well, and that was because of a fuel leak. Engineers want to inspect the spacecraft, the rocket, and do some repairs, and that might require the rocket to be moved back to the workshop, so it'd be rolled away from the launch pad, and that would lead to some setbacks of several weeks. Much of the thrust of the SLS comes from burning 3 million liters of liquid hydrogen and oxygen in the 4 big engines. But an alarm indicating a leak sounded when the command was sent early on September 3rd to fill the hydrogen tank. The problem was found to be a connection where the hydrogen was being pumped into the vehicle. A number of fixes were tried on the launch pad, some troubleshooting, but ultimately nothing worked, and the launch had to be scrubbed. And though the seal and the work to fix it could be completed on the launch pad, there are batteries in the termination system that are used to destroy the rocket in the event of a wayward launch that would require recertification after a certain amount of time. And that recertification can only be done in the workshop. And so NASA is trying to get a waiver from the US Space Force to extend the window before recertification. So that recertification window is like 20 days. They've already had a waiver to extend it to 25. Now they're trying to get it to extend it a little bit further. And as far as I could tell when I was writing this up over the weekend, that has not happened yet. If they get the waiver, then the next launch attempt could be as soon as September 23rd, if the leak is repaired, with a backup date of September 27th. If the bid to get the waiver is unsuccessful, then the launch will be pushed into mid-October because they will have to roll the spacecraft back to the workshop and do the work there. For the time being, work on the repairs is being done at the launch pad. The first attempt, as I mentioned, was on August 29th, when the controllers couldn't be sure that the 4 big engines at the base of the core stage were at the correct operating temperature. Frustratingly, the analysis that was done later showed that the sensor in question was almost certainly outputting inaccurate readings, and that in all probability things were probably good to go. But of course, this is a very important mission, and no one's taking any chances here. And so a few delays, but hopefully when it goes, it will go well.
Yeah, well, as we were saying before, they do historically the first missions don't tend to go that well. We have gotten our percentage of successful launches up, but getting to space is really, really hard. The gravity of Earth here is not to be underestimated. From our tiny, tiny, tiny human perspective, it is really quite the thing. And as we were talking about Luna 2 earlier, well, there's a reason it was Luna 2 and not 1. So I'm really hoping Artemis can, not follow this trend. And I think the safety first is absolutely the way to go.
Agreed, 100%. There was, I think it was CBC News talked to David Saint-Jean, who is one of our Canadian astronauts, and his comment was, the little boy inside of me was like so disappointed, but the engineer in me was like, yeah, that was the right call. Right. Better to delay and make sure everything's good than to ruin your $1 billion toy.
And it is worth mentioning,
however many dollars worth of it is. I don't even know.
Yeah, it is well over budget. So I think it's probably best if we don't discuss the cost. But yeah, the trying to launch it correctly without any errors on the first go is very hard, and a lot of people will compare Artemis to the SpaceX Starship, which doesn't have quite as high capacity yet, but might at some point. And the Starship has already had several tests and pretty spectacular failures, and it looks to be catching up quite quickly to the the sort of Artemis craft here. And it is the SLS is an kind of an amazing amalgam of various technologies come together, but these things do often fail, and it's catching it is a good sign, I hope. And these are not the only people to have recently scrubbed. In this actually same period of time, we had, what was it, last week or something, Blue Origin, they scrubbed their rocket with a booster failure. And they actually activated the abort system during an uncrewed launch. And Firefly Aerospace, who you might not have heard that much about before, they're actually ready to launch their launch vehicles. It's again a private aerospace firm, Firefly Aerospace. They were actually developing launch vehicles. They were ready to go, and they scrubbed. So they're right now waiting as well. So they're out at Vandenberg Space Force Base, I think, is what that's called. So Firefly's scrubbed recently. Blue Origin scrubbed recently. It's not just Artemis 1.
Oh yeah, no, not at all. It sounds like Artemis 1 had, I mean, it was, or sorry, not Artemis. Blue Origin was a little bit more than a scrub, though, wasn't it?
Yeah, that was a little more extreme. That was a actual booster failure, and they did activate their abort system. It was an uncrewed launch, so no human danger. So it was a payload mission with no astronauts on board. Because they actually did the abort on the system, they did have their capsule escape system go, and the capsule escape system did function, they say, as designed, but it has been mentioned that if you had been in there, you probably would not have had a great time because it was a bit bumpy, and it was all a bit crashing. So the rocket booster actually did crash back to Earth, and this was not a what did I call it before? An impact. This was a crash. This was an accident, but there are no injuries. It wasn't a crewed flight, and they did actually trigger the capsule escape system, and the capsule landed safely, and the booster impacted within the designated hazard area. So it was a pretty good failure, if you can say that any failure is good. But it is also an anomaly, right? So they don't they were not expecting this to happen, obviously, or they wouldn't have gone through with the launch. So this is another thing that Artemis 1 is trying so hard to avoid. So it's repeated launches have succeeded on Blue Origin, and I think this is the most recent crash that I have heard of from them. But it is they're still doing some exploration, I should say, about what might have gone wrong in this particular case.
Yeah, I imagine it's all research hands on deck to analyze and figure out exactly what went wrong. And
yeah, well, and once they do crash, you really can't use that rocket anymore. So that's it's a big problem for especially things like Artemis 1. If it doesn't fail, they literally have to, or if it doesn't succeed and it crashes and burns, they literally have to build the whole thing again.
Right. So the Blue Origin one took off to a certain height before.
Yeah, I'm not sure what how high it got, actually. I'm not sure that was in the article that I read, but it was a booster failure. So they got up to the booster stage, and the booster rocket then crashed back on Earth. and they had to trigger the capsule.
Oof, scary. Glad they're finding that out in the uncrewed phase.
Yes, and very glad this didn't happen to Artemis. So there's always that.
All right, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been myself, Jeannie Tomei, and Dr. Elena Hyde. Stay tuned because it is Astronomy Night in Canada. Up next is Quarks and Quarks, Western Worlds and Science for the People. Thanks for tuning in, and clear skies. Have a good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world.